Good? Test? That's better. Okay. Can we restart my time? All right, thanks. Hi, everybody. My name is Joe Sleppy. I'm the CEO of Capacitech Energy, and this is a picture with me and my team after we completed a National Science Foundation SBIR grant where we created this, a cable-based capacitor, basically a wire that can store energy to complement the $50 billion rechargeable battery industry. Turns out when people get solar panels, they're really excited at first, but that excitement turns into a disappointment. They find out the panels aren't as good as they thought, and then tax incentives start to expire. Then you got to replace a battery after 5 years, and that battery is going to cost you 30 grand over a 20-year period. Kind of stinks. And the root of that cause is that solar panels aren't as good as people hype them up to be. A 17% shadow coverage can result in 43% of lost power. As for the batteries, they're not designed to deliver every type of powered load in your home. Sometimes they're just not that efficient at it, and they can lose 35% of their performance just trying to do a job that they weren't designed to do. And so we are commercializing a new type of energy storage component called a cable-based capacitor. This is a capacitor that can complement a battery so that it has more performance and longer operating life. That means you replace your batteries less often. Also, it's thin and it's flexible, which means we can embed it inside DC power cords rather than putting it on circuit boards, making things larger and larger. So if we look at a typical home, you've got photovoltaic panels connected to charge controllers, connected to batteries, all with DC power cords. We want to splice our cable-based capacitor inside those DC power cords so that you get the capacitance, improving efficiency, and making a lot of other great things happen, such as making your panels resistant to shadow. When that shadow crosses over, instead of losing the power, the capacitor will discharge, keeping the output consistent. Also, we'll complement that battery to have more performance, and all in all, this will save about $20,000 over a 20-year period. As for the competition, most people focus on materials with capacitors, and this has not worked out very well in the last decade for startups. So we're focusing on form factor instead. By being able to put this inside of a DC cord instead of on a circuit board, using it off of the circuit, we create a lot of different opportunities that have never been seen before, creating a new segment in the capacitor industry. Also, it reduces inventory costs and lead time for distribution companies, so we add value to them as well. That's actually a really big deal because those people pretty much sell to the end user. Last but not least, because our intellectual property is so unique, focusing on the form factor, we are able to actually have more licensing opportunities and private labeling opportunities as well. Right now, we're starting with solar, and we're starting with solar because we have a quick-to-adopt opportunity with solar. People are innovative. People are willing to try. And then we're going to be scaling the same value proposition into information technology, healthcare, such as exoskeletons with Lockheed Martin, electric vehicles, and wind turbine. Last but not least, we've collected a lot of letters of support from Fortune 500 companies such as Jabil and Mouser, and altogether these letters of support describe the willingness to do pilot programs and also to generate about $4 million in sales in the next year or two. Thanks.
Go ahead.
Sorry, I meant to give you guys a sample. This is a real working capacitor. You can bend it if you want. It's about 4 millimeters wide, 10 centimeters long, and it has 2 farads of capacitance. So that means it could deliver 2 amps in 1 second or vice versa.
Great. Staying in solar with the team you have today, what's your plan to get it to market? How do you get out and let people know you're alive?
So we're working with a company that's local to us called UMA Solar. They're a large equipment distribution company, and they're basically being our sales and marketing force to solar installation companies. They're telling us exactly the specs we need to have, exactly how our marketing should look, and so that's a really great partner. Also, my team isn't just me. I have Dr. Isaiah Olade. He's our CTO. I also have Sabby Prasad sitting in the crowd. She's doing our chief of sales and marketing type work, and all together we have some experience in solar, and we're driving that home. We're setting up pilot programs right now. That's the next step.
What are your steps to a marketable product?
So first thing is we need to set up a more scalable manufacturing. So currently we can only make about 10 units by hand, and that's not very scalable. So we're implementing a manufacturing line so that we can do larger orders and do larger pilot programs. That's the first step. The second thing that we really need is to get a UL certification, which is kind of like FDA approval for electronic components. Those 2 things are what those letters of support identify. If you can show that you can produce this on a regular basis with a secure supply chain and you're able to get the UL listing, I'm willing to buy X amount from you.
So at scale, how many of these would go into a typical solar application? So
A
if I have
typical-
one solar cell, how many of these capacitors would typically fit into it?
Right, so a typical solar home will have typically a 60-volt system with a 48-volt battery. None of that really matters. What's going to be is we'll sell our product for about $350 to $500 depending on how many solar panels you have connected. And so that would be about 100 cells of our capacitor.
Okay. And then the SBIR grant that you got, that you actually received that grant?
We received and spent $225,000 to develop the technology. That's a real working prototype. Yes. You can talk to me later if you want.